This is a summary of the relationships in a 30, 60, 90 triangle. There are really two parts here that I want to show you. The first part is fairly easy. If you I want to generalize this, use some algebra. So I'm going to say that this side of the 30, 60, 90 triangle has a length of a, just an arbitrary number. You could say 1, you could say 2, but if you talk about it in a general sense, you'll see how that has some power. So the first part here, if you were to flip this triangle around its long leg, over its long leg, the 60-degree angle would flip around here, this would be another 30-degree angle, and all of a sudden you see that all the angles are 60 degrees, which means you have an equilateral triangle. So if you go to the original A, the part we flip is going to create another length of A, which means the whole side of the equilateral triangle is 2A, which means this side is 2A, and most importantly, the hypotenuse of our original triangle is 2A. So the first relationship in a 30-60-90 triangle is this fairly easy one, that the hypotenuse, the longest part of the triangle, the hypotenuse, is twice the short leg, the one that's opposite the 30-degree angle. So the short side, opposite the 30-degree angle, is doubled to get the hypotenuse. Or if you have the hypotenuse, you take half of it and you have the short leg. So that's a nice relationship. This can also be looked at with the Pythagorean theorem. We can stretch this relationship along and find out how long is the long leg. So the Pythagorean theorem applies to every right triangle. We have one here. It says 1 leg squared, a squared, plus the other leg squared, which is the thing we're looking to find next. 1 leg squared plus the other leg squared equals the hypotenuse squared. So that's saying 2a times 2a, the hypotenuse squared. And that, using the commutative property we've talked about in class, can be rearranged to be 2 times 2 times a times a, and that, of course, 2 times 2 is 4, a times a we just did is a squared. So the Pythagorean theorem says that 1 leg squared, a squared, plus the other leg squared, the unknown, squared, equals 4a squared. So 1a squared plus something equals 4a squared. 1 something, which is an a squared, plus an unknown length equals 4a squared. Well, if it were 1 apple and something equals 4 apples, we'd say that the question mark squared is equal to 3 of the somethings, 3a squared. We're really just subtracting a squared from both sides, or balance. So the length of the side, the long side, is the square root of 3a squared. And here's where we have simplified radicals in the past. If we have a perfect square inside the radical, it can come out. So the square root of a squared is just the a, and the 3 is all by itself. It cannot come out. So a root 3. So what is this saying? Well, this is saying if you know the short leg, you can go to the long leg by taking a and multiplying it by root 3. Now when I write that, typically I write that as root 3a. It's still root 3 times a, or a times root 3. It doesn't matter which way you write it. I usually write it as the root 3a because that makes, I usually write it as a root 3 because that makes it clear that the a is not underneath the radical anymore. So the short leg is a, you multiply by root 3 to get the long leg, or if the short leg is a, you double that to get the hypotenuse. So there's the relationship in the triangle. The short leg is kind of the hinge. You multiply by root 3 to go to the long leg. You would divide by root 3 if you're coming back the other way. To go to the hypotenuse, you multiply by 2, or if you're coming back the other way, you divide by 2. That's the relationship. Let's look quickly at just some quick examples. If you're given the short leg, let's pick any length. It could be 4. If that's the a, you double it to get the hypotenuse, which would be 8, and you multiply it by root 3, the short leg by root 3, to get the long leg. So whatever you're given, you double the hypotenuse. Whatever you're given on the short leg, you multiply by root 3 to get the long leg. That's fairly easy. If you're given the hypotenuse, let's suppose the hypotenuse was 12. You would take half of it, to go to the short leg, so that would be 6, and then you would multiply by root 3 to get the long leg. The hardest ones are when you're given the long leg, and I'll do 2 with the long leg. First, if you were given 8 root 3, you would divide by root 3 to get to the short leg, and that would be 8, and then you would double it to get to the hypotenuse, which would be 16. The short leg is the hinge. Now it's a little bit different if you have a number that doesn't have the root 3, it's not 8 times root 3. Suppose the number, we'll finish those. Now let's move on. Suppose we have this number was 12. If this number is 12, we want to divide by root 3 to get the short leg. So we're going to take 12 and we're going to divide it by root 3. Now we've done work with radicals and we don't want radicals in the denominator, so we're going to multiply by root 3 over root 3, which is just a form of 1. And that changes what this looks like. Now it's 12 root 3 over root 3 times root 3 is 3, and 12 thirds is 4. 12 root 3 divided by 3 is 4 root 3. If we know the short leg is 4 root 3, then we double it to go to the hypotenuse, and we get 8 root 3. So there's a relationship that this is perhaps the hardest one. When it doesn't have the root 3 already in it, you still have to divide by root 3 to go to the short leg, and you have to multiply, double it to get to the hypotenuse. I hope that helps. It's a summary of our work with 36 triangles.